Numerals take their places. Positional numbers. In context, key civilization Babylonians. Field arithmetic. Before 40,000 years ago. Stonehenge people in Europe and Africa count using tally marks and mortar bone. 6,000 to 5,000 BC, Sumerians developed early calculation systems to measure land and to study the night sky. 4,000 to 3,000 BC, Babylonians used a small clay cone for 1 and a large cone for 60, along with a clay ball for 10 as their base 60 system evolves. After 2nd century, the Chinese use an abacus in their base 10 positional number system. 7th century, in India, Brahmagupta establishes 0 as a number in its own right and not just as a placeholder. It is given to calculate, to weigh, to measure, to observe. This is natural philosophy. Voltaire, French philosopher. The first people known to have used an advanced numeration system were the Sumerians of Mesopotamia, an ancient civilization living between the Tigris and Euphrates rivers in what is present-day Iraq. Sumerian clay tablets from as early as the 6th millennium BC used symbols denoting different quantities. The Sumerians, followed by the Babylonians, needed efficient mathematical tools in order to administer their empires. What distinguished the Babylonians from neighbors such as Egypt was their use of a positional number system. In such systems, the value of a number is indicated both by its symbol and its position. Today, for instance, in the decimal system, the position of a digit in a number indicates whether its value is in ones, tens, hundreds, or more. Such systems make calculation more efficient because a small set of symbols can represent a huge range of values. By contrast, the ancient Egyptians used separate symbols for ones, tens, hundreds, thousands, and above, and had no place value system. Representing larger numbers could require 50 or more hieroglyphs. Using different bases. The Hindu-Arabic numeration that is employed today by a base 10 system. It requires only 10 symbols, 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 0 as a placeholder. As in the Babylonian system, the position of a digit indicates its value, and the smallest valued digit is always to the right. In a base 10 system, a 2-digit number such as 22 indicates 2 times 10 to the power of 1 plus 2 is the value of the 2 on the left is 10 times that of the 2 on the right. Placing digits after the number 22 will create hundreds, thousands, and larger powers of 10. A symbol after a whole number, the standard notation is now a decimal point, can also separate it from its fractional parts, each representing a tenth of the place value in the preceding figure. The Babylonians worked with a more complex sesquidecimal number system that was probably inherited from the earlier Sumerians and is still used across the world today for measuring time, degrees in the circle, and geographic coordinates. Why they use 60 as a number base is still not known for sure. It may have been chosen because it can be divided by many other numbers, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. The Babylonians also based a calendar year on the solar year. The number of days in a year was 360 with additional days for festivals. In the Babylonian sexagesimal system, a single system was used alone and repeated up to 9 times to represent symbols from 1 to 9. For 10, a different symbol was used, placed to the left of the 1 symbol, and repeated 2 to 5 times in numbers up to 59. At 60, 60 times 1, the original symbol for 1 was reused but placed further to the left than the symbol for 1. Because it was a base 60 symbol, two such symbols signified 61, while 3 such symbols indicated 3,661, that is 60 times 60, 60 squared, plus 60 plus 1. The base 60 system had obvious drawbacks. It necessarily requires many more symbols than a base 10 system. For centuries, the sexagesimal system had also no place value holders other than to separate whole numbers from fractional parts. By 300 BC, however, the Babylonians used 2 wedges to indicate no value, much as we use a placeholder 0 today. This was possibly the earliest use of 0. I'm waiting for the page to turn. Okay. Other counting systems. In Mesoamerica, on the other side of the world, the Mayan civilization developed its own advanced numeration system in the first millennium BC, apparently in complete isolation. Theirs was a vigesimal number system which probably evolved from counting a simple method using fingers and toes. In fact, base 20 number systems were used across the world in Europe, Africa, and Asia. Language often contains remnants of this system. For example, in French, 80 is expressed as called the 20, 4 times 20. Welsh and Irish also expressing numbers as multiples of 20, while in English a score is 20. In the Bible, for instance, Psalm 90 talks of a human lifespan being 80 years and 10 or as great as 80 years. From around 500 BC until the 16th century, when Hindu-Arabic numbers were officially adopted in China, the Chinese used rod numerals to represent numbers. This was the first decimal place value system. By alternating quantities of vertical rods with horizontal rods, this system could indicate ones, tens, hundreds, thousands, and more powers of 10, much as the decimal system does today. For example, 45 is written over 4 horizontal bars representing 4 times 10 to the power of 140, and 5 vertical bars for 5 times 1 times 5. However, 4 vertical rods followed by 5 vertical rods indicated 405. 4 times 110 to the power of 2, or 10 squared, plus 5 times 1. With the absence of horizontal rods meant there were no tens in the number. Calculations were carried out by manipulating the rods on a counting board. Positive and negative numbers were represented by red and black rods, respectively, of different cross-sections, triangular and rectangular. Rod numerals are still used occasionally in China, just as Roman numerals are sometimes used in Western society. The Chinese place value system is reflected in the Chinese abacus, swanpan. Dating back to at least 200 BC, it is one of the oldest bead counting devices, although the Romans used something similar. The Chinese version, which is still used today, has a central bar and a varying number of vertical wires to separate ones from 10 tens or more. In each column there are 2 beads above the bar worth 5 each and 5 beads below the bar worth 1 each. The Japanese adopted the Chinese abacus in the 14th century and developed their own abacus, the soroban, which is 1 bead worth 5 above the central bar and 4 beads each worth 1 below the bar in each column. Japan still uses the soroban today. There are even contests in which young people demonstrate their ability to perform soroban calculations mentally, a skill known as zanzan. Cuneiform. In the late 1800s, the academics deciphered the cuneiform wedge-shaped markings on clay tablets recovered from Babylonian sites in and around Iraq. Such marks denoting letters and words as well as an advanced number system were etched on white clay with either end of a stylus. Like the Egyptians, the Babylonians needed scribes to administer the complex society, and many of the tablets bearing mathematical records are thought to be from training schools for scribes. A great deal has now been discovered about Babylonian mathematics, which extended to multiplication, division, geometry, fractions, square roots, cube roots, equations, and other forms because, unlike Egyptian papyrus scrolls, the clay tablets have survived well. Several thousand, mostly dating from between 1800 to 1600 BC, are housed in museums around the world. In this picture, the Babylonian-based number system was built from 2 symbols. The single unit system used alone and combined for numbers 1 to 9, and the 10 symbol repeated for 20, 30, 40, and 50. The Babylonian and Assyrian civilizations have perished, yet Babylonian mathematics is still interesting, and the Babylonian scale of 60 is still used in astronomy. G.H. Hardy, British mathematician. Modern numeration. The Hindu-Arabic decimal system used throughout the world today has its origins in India. In the 1st to 4th centuries, the use of 9 symbols along with 0 was developed to allow any number to be written officially through the use of place value. The system was adopted and refined by Arab mathematicians in the 9th century. They wrote the decimal point so that the system could also express fractions of whole numbers. Okay. 3 centuries later, Leonardo of Pisa, Fibonacci, popularized the use of Hindu Arabic numerals in Europe through his book Liber Abaci, 1202. Yet the debate about whether to use the new system rather than Roman numerals and traditional counting methods lasted for several hundred years before its adoption paved the way for modern mathematical advances. With the advent of electronic computers, other bases became important, particularly binary, a base system with base 2, a number system with base 2. Unlike the base 10 system with its 10 symbols, binary just has 2, 1, and 0. And it is a positional system, but instead of multiplying by 10, each column is multiplied by 2, also expressed as 2 to the power of 1, 2 squared, 2 cubed, and upward. In binary, the number 111 means 1 times 2 squared plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. That is 4 plus 2 plus 1, or 7 in our decimal number system. In binary, as all modern number systems, whatever their base, the principles of place value are always the same. Place value, the Babylonian legacy, remains a powerful, easily understood, and efficient way to represent large numbers. The fact that we work in tens as opposed to any other number is purely a consequence of our anatomy. We use our 10 fingers to count. In this picture, Ibisu, the Japanese god of fishermen and one of the 7 gods of fortune, uses a sotobon to calculate his profits in The Red Snapper's Dream by Utagawa Toyohiro. Mayan numeral system. The Mayans, who lived in Central America from around 2000 BC, used a base 25 number system from around 1000 BC to perform astronomical and calendar calculations. Like the Babylonians, they used a calendar of 360 days plus festivals to make 365 days based on the solar year. Their numbers helped them work out the growing cycles of crops. The Mayan system employed symbols, a dot representing 1 and a bar representing 5. By using combinations of dots over bars, they could generate numerals up to 19. Numbers larger than 19 were written vertically, with the lowest numbers at the bottom. There's evidence of Mayan calculations up to hundreds of millions. An inscription from 36 BC shows that they used a shell-shaped system to denote 0, which was widely used by the 4th century. The Mayan number system was in use in Central America until the Spanish conquest in the 16th century. Its influence, however, never spread further.